Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazwan bin Muhammad Arif, and I will presenting on our project with H microwave pressure filter. And this project with my team member Umi Atika Miti Ismail. And firstly, we go to the introduction. Filter is a circuit to filter out unwanted frequency signal and only pass the desired signal through how the circuit designed. A low pass filter circuit is a circuit that provides simple passage to filter out unwanted signal that signal high frequency and allow low frequency. So firstly, we go to design a thin network low pass filter LUM element. The specification given below is frequency cutoff 1.8 GHz, frequency 4.9 GHz, and 30 dB insertion loss. So the RO is 50 ohm. It will design with 3 dB equal ripple. So firstly, we need to find the value of N. To find the value of N, we need to find the omega cutoff frequency, which is 2 pi Fc, and we get 11.31 GHz. And we find the omega, use the 2 pi F, the value of frequency, and we get 30.79 GHz. So to find the value, we need to divide omega with omega cutoff frequency and subtract by 1, and we get 1.72. To get the value of N, we need to refer to this graph. Our value of dB is 30, and the value that we calculate just now 1.7 in here, so we must take above the value that we get, so we get N equal to 3. Next, we move to element according to N. G1, G2 and G3 is referred to the table of 3 dB equal ripple. Next, we find the value of inductor and capacitor value. So our N is equal to 3, and we have only 3 elements in the circuit. Firstly, we design the T network low pass filter. So element, it must be inductor. So the value of inductor, using the formula RO multiply by G and divide by omega cutoff frequency, and we get 14.8 nanohenry. Also same for the capacitor, but with different formula. The G divided by RO multiplied by omega cutoff frequency, and we get 1.2 picofarad. So the value of G for L3 is equal to L1. Next, okay, this is our circuit design. We design with 1 GHz until 5 GHz with step response 100 kHz. So the T circuit is like this for a low pass filter, and we'll get the step response at the cutoff frequency 1.8 GHz at 3 dB. So this circuit is correct because at 3 dB it must be cutoff frequency, and our attenuation is 30.197 dB at 4.9 GHz. So next, we move to design T network low pass filter distributed. So we need to convert from the low pass filter into the stub using Richet transformation. For the inductor value, we just take the value of G that we get, and for the capacitor value, we need to divide 1 by the value of G, and we get the value here which is 1.4051. Then inductor for the third element is also same for the first element. Then we convert the circuit to the Richet transformation. So the inductor will be closed circuit and capacitor will be open circuit like this. So this is uh, the circuit that we have to implement. Next, we use Kuroda identity formula to get the value for each stop. Z2 Z2 is the transmission line. Transmission line is 1. Z1 is the value of here. So we need just only to calculate one because this one and this one is same value. So we need to calculate the n square. 1 plus by 1 divided by Z1. 1 is Z2 and here is Z1. And we get 1.3. 1.3 we will use this value for n square Z1 and n square Z2. For n square Z1, the value of n square Z1 will multiply by 50 and we get this. This also same and we get 50 to denormalize the value. So this is the equivalent circuit illustrating to Kuroda ITT and illustration low pass filter transmission line. So after we multiply by 50, this is the equivalent circuit. All the circuit must be open circuit for n equal to. This is the layout, illustrating layout. This circuit design implementation in NDS. This is MLIN and this is MLOC. MLOC is the value of n must be 3. 1, 2, 3 for all the stuff. And Z not is equal to 50 and RL equal to 50 because G4 is equal to 1. So we need 1 multiply by 50 is we get 50. This MLIN, the value of width and length, we use line cal in NDS and synthesize the value using the information that we have and we get the value here. Also same for the MLOC, 3 MLOC and others stuff. So this value we get from here. Width for the width 1 is here, width 2 is here and width 3 is here. So just input the width here according to the where it's come and each stop. So the step response that we get is the frequency cut off must have 1.8 gigahertz. So at a 3 dB here we get 1.8 gigahertz. So for the attenuation we get 4.9 at 22.757 dB. Okay, this is layout that implement from NDS circuit and we get this layout. This layout is according to the ZO and this is the RL. This is the MLOC 65, 70 and 65 and this is MLIN. So this is the layout for the transmission line stuff. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Umi Atika binti Ismail from 3BEET section 11. Here I'm going to continue in explanation on how to design LUM band pass filter. First and foremost, this is the specification given that consists of center frequency with insertion loss 3 dB, 50 ohm for impedance, and the number of order filter which is equal to 3. So we are required to design this band pass filter with equal ripple filter implementation. The the specification given. We just need to develop this specification to find the lower cut-off frequency, which is F1, that equal to 1.71 gigahertz, and upper cut-off frequency, which is F2, that equal to 1.89 gigahertz. After that, we need to find the omega naught, omega 1, omega 2 by develop basic formula to find omega, which is 2 pi f. Then, after we got the omega values, we need to find fractional bandwidth. We will use omega 2 minus omega 1 and divide by omega naught, and then we got 0.101. Then this is the values of each element according to number of order filter, which is n equal to 3. As mentioned before, we know that value of n is 3. We need to determine the number of side filter, which is G1, G2, and G3. By referring attenuation versus normalized frequency for 3 dB ripple level and their element values. So this is the element values. After that, we develop the element values to find the inductor and capacitor values. To find these values, we will develop conversion formula, which is L1 and C1. L1 and C1, we use shunt formula LC. For L2 and C2, we use series formula LC. And for L3 and C3, we will use shunt formula LC. L3 and C3 will get same values with L1 and C1, as they just develop same formulas. After we accomplish the calculation for each element, we can construct the circuit design. So this is our circuit design implementation in ADS software that consists shunt LC, which is in parallel condition for L1 and C1. This is series L2 and C2 in series condition, and this is shunt L3 and C3, which is in parallel condition. So this is a component for 50 ohm impedance for term 1 and term 2. However, before we simulate this design, we need to set up as parameters in order to produce step response with smoothly result. We just need to adjust at the start, stop, and step size. Finally, this is the step response plotted graph. We use marker function to show the F1, F0, and F2 values as expected values in the calculation. That's all from me. Thank you, and Assalamualaikum warahmatullahi wabarakatuh.